Hello students, welcome to physics class. Today we starting a new chapter in physics, work and energy. Chapter 11 from NCERT textbook. First let us see what is work. Or when you say work is done. The work is defined like this way. Work is said to be done whenever a force acts on a body and the body move through some distance in the direction of force. The work is said to be done whenever a force acts on a body and the body moves through some distance in the direction of force. Now let's see how can we measure a work. Work done by a constant force. Suppose here we have a body, a block of mass m. This is the center of this block which is placed on this horizontal surface. A force F acts horizontally on this body. It's a constant force. By the action of this force, suppose the body displaces. After the application of this force, the force acted on this body, the body moved through a distance s. Say the displacement of the body is s. After the action of this force, this is the center of the body. This is the position of the body after applying the force. So the distance between the final position and the initial position is s. So it's a straight line distance. So this is the displacement. S is the displacement. So we can say after acting this force F, the body displaced. The displacement is S. So by the definition of work, work done is equal to force into displacement. If the object is displaced in the direction of applied force, we can simply write the work done is equal to force into displacement. The work is usually denoted with a symbol W, force F and displacement S. So the work is equal to W is equal to F into S. The SI unit of work is the SI unit of force into SI unit of displacement, Newton meter. And 1 Newton meter is equivalent to Joule. Joule is the SI unit of work done. Either you can say it is Newton meter or Joule. 1 Newton meter is equal to 1 Joule. So in this equation, if you substitute F is equal to 1 Newton and S is equal to 1 meter, you will get the work is equal to 1 Newton meter. 1 Newton meter is equal to 1 Joule. So we'll define 1 Joule as 1 Joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. That is 1 Joule. 1 Joule is defined like this way. 1 Joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. That is 1 Joule. You see that work is a scalar quantity. No, force is a vector quantity and displacement is a vector quantity. But the work is a scalar quantity. There is no direction for the work. And the SI unit of work is Joule. The work is a scalar quantity. There is no direction for the work, even though the force and displacement are vector. Now see, the work done can be positive or negative or even zero. Let us see in what situation work is positive, negative and zero. Positive work. If a body displays in the direction of applied force, work is said to be positive. For example, in this situation, here this is the direction of the applied force and the object displaces in the direction of applied force. So by the time we can say the force or the work is positive. The work done by this force is positive. The angle between the applied force and displacement is zero. Theta, the angle between the force and work is equal to zero. the angle between the force and displacement is equal to 0. So work is equal to positive. Example, in this situation, if you are applying the force, the body displays in the direction of applied force. So angle between the force and displacement is equal to 0. The work is equal to positive. Another example, when a body falls freely under the gravity, the work done by the gravity is positive. We know that once an object is falling under gravity, suppose an object is falling towards the earth under gravity, only the force acting on this body is gravitational force. So actually the earth is pulling this object towards it. Earth is pulling this object towards it. So this is the direction of gravitational force. The body displaces in the direction of force. The angle between the force and the displacement is 0. So that force is also, that work is also positive. That is positive work. If the body displaces in the direction of applied force, then the work is said to be positive. Remember the example. Now, negative work. If a body displaces in opposite direction of applied force, work is said to be negative. If the body displaces opposite direction of applied force, then the work is negative. For example, suppose if you are lifting an object, if you are lifting a particular object h above the surface of the earth, in order to lift this object, we are doing some work. We have to apply some work, or we have to apply some force. But gravitational force is acting just opposite direction of that force. So by the time we can say the work done by the applied force is positive, but work done by the gravitational force is negative. The reason is that the gravitational force is acting opposite direction of that displacement. The object is displaces opposite direction of gravitational force. So the work done by the gravitational force, once we are lifting an object above the surface of the earth, the work done by the gravitational force is negative, but work done by the applied force is positive. So that is negative work if the object displaces opposite direction of applied force. That is, angle between the force and displacement is 180 degree. Here, this is the direction of gravitational force, but this is the direction of displacement. Angle between them, they are in opposite direction. So angle between them is 180 degree. So the work is negative. Then sometimes work can also be 0. Suppose even the force is acted, if the object is not displacing. In this situation, suppose the object is not moving. The displacement S is equal to 0. Then we can say work is equal to F into 0. Then the work is equal to 0. Suppose if you are moving an object through a circular path, by applying a force, we are displacing the object through a circular path. If the object is reached finally this point itself, the displacement is 0. No work done. If the displacement is 0, no work is done. Then another situation, the work can also be 0 if the force is acting perpendicular to the displacement. If the force is acted in this direction, if the object is displacing perpendicular to the direction of applied force, that is, if the angle between the force and displacement is equal to 90, then we can say the work is equal to 0. So there are different possibility for work is equal to 0. If the object is not displacing, the work is equal to 0. If the force and displacement are perpendicular, we can say the work is equal to 0. If the object is returned to the final position, if the object is returned to the initial position itself, the displacement is equal to 0, no work is done. So work can also be 0. So work can be positive, it can be negative, or even it can be 0. That's all about work. Thank you.